whether the model is valid statistically. That is the first one, using the log likelihood output from the computer. Then the model can be considered further. Then are all the coefficients present or not? Before doing that, I look at the R squared. I use McFadden R squared as a recommendation, but you can use anything. It is a pseudo R squared. It is a conservative R squared is McFadden, and I look at that to what extent it can capture the uncertainty present in the intercept model by the full model. Then the third one, if so, can I test the individual coefficient significance, which you correctly said the p-value and all that will come there. Then out of the individual coefficient significance, we found only Brand is important, the other two are not important. Prima facie, I put a question mark, but when I look at the odds, they are also important. And then the fourth one, explanation of the odds. The fifth one is the classification. The sixth one is the ROC curve. In this order, I suggest to all of you, look at the output of the logistic regression. Okay, this is the order. This is suggested by this because the order is logical. If the overall model is not valid, why do you worry about the individuals? Okay. Now, there is one more thing I just want to say here, that when I look at all these things, you have to summarize this part, that whenever the variable is significant and the odds are also more than 1, it is the best thing that can happen. Variable is insignificant, statistically not significant, odds are also less than 1, then it is of no use. But variables are not significant, odds are showing more than 1, I cannot ignore those variables. And those are the learning takeaways of the powerful tool logistic regression. Some of the practitioners, some of the theoreticians also respect this. There is always a difference between a statistical significance and a practical significance, a theory and practice. The second example, yes.
Many of the softwares, they are doing elimination kind of this one, right? Variables, they just keep,
Yeah.
and then you eliminate one
Yeah.
by one,
Yeah.
see, which is the best one.
Yeah.
Similarly, reverse
Yeah.
also now
Yeah.
they're doing. What is the
Yeah. Now, that is called the stepwise method, forward pass and the backward pass, similar to the project network program evaluation review technique. The best subset of hundreds of variables, here you got only 2, 3 as an example, hundreds of variables are there. What is the best subset of those which will give me the best pseudo R squared, which is that best subset I cannot arbitrarily do, the computer do it by a stepwise method, then select those. Now, there is a criticism when you do that. Neural network and random forest says, this is the problem of logistic regression. Why should I do? I will take all the variables. Random forest will do it for me. Ignore logistic regression. Just to throw it into the Bay of Bengal, which is nearby. That is what they say. So, random forest and neural network, they say predictive accuracy. I am not testing hypothesis. I will go by variable importance, Gini index or something like a cart. I grow 500 trees and select the best tree. I will take all the variables. Based on the importance, later on you remove something if you want to. So, there is a criticism. Then the logistic people say, oh, yours is a black box. Can you tell me if X increases by 1 unit, what will happen to Y? Nobody in the world will be able to refute that, it is a black box. So, can I make the black box as a white box? The answer is yes. You take logistic regression, the important variables, build a neural network, it will work better. So, that is something else, but I have answered that part to you. Now, the next example is a mailing strategy, which I will quickly cover to you, the practical value. 2,000 customers, 1,000 customers the holdout sample, 1,000 customers the existing customers, and actually those who bought, it is a case dealing with art history of Florence, that is the name of the book. How many people will buy the new title book, and those who are interested in the history type of a thing. So, if out of the 1,000 existing customers, only 8.3% or 83 people only bought that out of 1,000. So, 8.3% only currently buying. Something like a Reader's Digest strategy, you would send it to 10,000, only 100 may buy, whatever. So, the company sent a testing mail to them. In this regard, the company also sent out an identical mailing to another 1,000 customers to serve as a holdout sample. Holdout sample is kept separately. That is, in your analytic world, you say it is the test data, training data and test data. The scope of the study is confined to predicting whether a customer will buy the new book or not. is based on two input variables, months since last purchase and number of art books purchased, the past. These two variables are taken, and these are given in two Excel files, Paul Books 1, Paul Books 2, which are given. Then now we take this output quickly. So it gave the model is valid, and overall the chi-squared, this is very small, it is a valid. So model is able to do a statistically powerful method of classification. Then I have the R squared is moderate, 12%, it is not very high, McFadden R squared. I will just come to that and all that. So the model has explained it, but the goodness of it is rather modest or bordering between average and just above average. It is not very high. Now, estimates, months are significant, no, number of books bought is also significant. Now you must know, even when you do regression, some cases R squared will be only even 9% or 10%, but the individual variables may be significant. That shows maybe you have not taken other variables. So here I have taken these two, and I am able to say both are statistically significant in spite of a moderate R squared. So this is the individual coefficients, both are significant. Overall the model is valid, and therefore I can use it for predicting. Then I come here to the odds. The number of books bought has the highest bearing, number of arts books bought is 2.68 compared to any other book that is bought. The arts, 73% probability, if somebody can buy one more art book, if you can, he will be a potential person for buying this new book, The Art of Florence. So this is the interpretation. Then I put here classification. The classification, if you see here, prediction, actual, prediction. It is called the confusion matrix because we are confused. The ability of the computer to correctly place is not happening, is misclassification. Its computer is confused, you may say. So out of 917 people who actually did not buy the book, they are not interested, the computer has predicted correctly 914, 3 it went wrong. Out of 83 people who bought this book, the computer predicted 75 not buying the book. It is a very big error, right? Because of that, my overall accuracy has improved, but I have committed a very big type 2 error. 83 actually bought, but the computer could predict only 8, 75 wrong, very high, be aware. And moderate R squared, pseudo R squared. Then the ROC curves also represents that. It is about 73%, but look at the bow of Rama, it is not fully extended. Now this is just moderate ROC plot. Now the question comes, your R squared, pseudo R squared is only about 12% or so, your ROC is 73% only. Even though the individual variables are significant, I agree, I have made a very big error in this second classification. 83 people it predicted only 8 is correct. Does it have practical value? Then the holdout sample, I tested this model for the holdout sample. The holdout sample also, the story is not different. It has done very well in predicting no purchase, but purchase out of the 81, only 5 have been correctly placed in the holdout sample. That is the test data. So is again a problem. So does it have any practical value to this book mail company for a mailing strategy? You are talking about logistic regression. What is the use? You are always having aggression, but aggression with caution, all those things will come. Am I right? So this is the question that we need to answer. This happens in life. You cannot get always very accurate one. Now we can assess the operational significance of the model by actually using it to determine the mailing strategy to all the 1,000. The cost of mailing is $1 to everybody, and if the customer responds favorably, you will buy the book, he or she, the profit is $6. Net profit after the cost of mailing is taken into account. What should the mailing strategy be? That is the practical power of logistic regression. Can it answer? Now, simple mathematics will tell, if I take P as the probability of success, 1 minus P as the probability of failure, in this case P will buy the book, 1 minus P will not buy the book. Whenever people buy the book, it is $6. When they do not buy the book, it is minus $1 loss, and I work out the inequality greater than 0. When the probability becomes 1 by 7, the threshold, then I have a break-even type of a thing. Whenever it is more than 1 by 7, I do not incur a loss, which is the expected value concept of the random variable in statistics, incidentally. A simple thing we put. In other words, the threshold probability, when it is more than 1/7, 1 upon 7, I can think of evolving a mailing strategy. For that, at least 1 by 7. In other words, in classification of the table, we always take 50% cutoff. That is why the odds and all. Now, I have not taken 50% cutoff. What I am saying, supposing your cutoff you take 1 by 7, where I do not lose $6 profit or $1 loss, the P has to be more than 1 by 7. Now, classification matrix for the holdout sample, when P is 1 by 7, you look at it.